All right. Good morning, everyone. We are going to continue to finish chapter 20 today. Last time we devoted one lecture on the comparator interface, and we get into the using the comparator interface and with a lambda expression. And the comparator interface is very useful, and we're going to use it a lot in our practical projects. So we are now going to continue in this chapter, and so we're going to finish the rest. And so here in section 20.7, static methods for lists and collections. So there's a very convenient methods you can use. In the Java API, there are some classes, and they just contain the static methods, like in the arrays class. So java.ut.arrays, so it has a lot of static methods you can use to process arrays. And here we have the static methods for lists and collections. So we're going to look at this static methods right here, and for lists and collections, and see, look at all those methods. Now I want you to go on your own time and to look at each method and write a test code for it. So how do you use the sort of the list? So there's another sort here, and it's to sort a list and using a specified comparator. So here is you specify how you're going to compare it and using this comparator. All right, so this is the in the collections. Look at this, the spelling here is collections. So this is a class. So we have an interface called a collection. So this is the collections. All right, so those are the methods here for the lists you can do with the lists. And those are the methods you can do with any collection here. Find the max. So how do you find the max? Using a specified comparator. So this is the first one, the overloaded method, max. And you find the max from a collection and using their natural order. And that's the comparable interface. So this is a comparator, and you specify a comparator. All right. So, so please read this and write your own test code and for the methods. All right, so we're going to go to the next one here. Now, this is the case study, bouncing balls. So we're going to use the data structure to build an interesting, and again, so here you see the user interface, and you have the plus button, minus button. When you have the plus button, so you're going to launch one ball, plus again, you launch another ball. And so using minus, you can remove a ball. So this is the ball moves on their own. And so how you track and manage all these balls and using a data structure to store it. So that's the case study here in this bouncing ball. So please study and this see how you design it and how you implement it and in Java FX. All right, I'm going to get to the next one here. And now this is the vector class and the stack class. Vector class is very similar to arraylist, the purpose. So you use the arraylist, you hold the collection of things. And you also using vector, you hold a collection of things. This is the in some order, so with an index. So this is the one. Now, this vector class is an old class in the Java API. It was introduced before ArrayList. So now we have the ArrayList. We normally don't use the vector anymore, but in the Java API, for the historic reason, and there are many system, the classes, and still use the vector. So we need to become familiar with vector. So this is here and the vector, and see how the vector is defined. It's a concrete class, and that's a subtype of abstract list. So going upward and all the way to the collection interface. So you're going to see how you use collection vector. Now, there's a key difference between vector and ArrayList is that in vector, all these methods that can change the contents of the vector, like add element, remove element, and all these methods are synchronized. So that means it has the internal mechanism to prevent multiple threads from accessing the data structure vector. So it is a good thing, right? You're not going to get data corruption. So you're going to, when you do it simultaneously, if you don't manage it, the synchronization, so it could have issue and corrupting your data. So it manages well. So that's actually an advantage. You're going to use this vector. The ArrayList doesn't have it. So you're going to say, hey, maybe vector is better than ArrayList. But you know that the issue is this. If you do this with all this, the synchronization, it costs time. So it's not efficient. In a lot of applications, when you write like your own code, and you don't have the multiple threads, so you're not really concerned about it or the synchronization at all. So in that case, you're going to waste a lot of time with this vector. So please note that in this class, we studied the data structures, and we choose the best data structure, most efficient for our applications. So that really has a big impact when you have a huge amount of data and you need to choose the right data structure and the efficient algorithm. All right, so here, see the vector, the difference between this vector and ArrayList. So for the ArrayList, you still can do a synchronization, but you just add additional code. So this is something beyond the scope of this class. Okay. So we're not going to cover any risk threads, multi-threading, concurrency programming in this course, but just know that, and this is the difference between vector and ArrayList. And so there's another class here, is very common. We all know it very well. It's a stack class. Well, the stack class is here. It's actually designed. This is very early days when Java was introduced. Java was introduced almost 30 years ago. It is the first time I got into Java was in 1995. So 1995. So you think about it, it's 28 years. So when Java was first introduced, in the early version, and they have a lot of classes already, and the design one is called a stack. Stack is, so that's a stack. You have data is the last in, first out. So the stack is designed as a subclass of vector. We still use it, but it's a bad example of design. You see why? Because right here, the stack has all these methods: empty, peek, pop. So pop is remove the top element in the stack and return that removed element, and push is push new one. All right, all this here, that's fine. But you see here is extends, means you're going to inherit all the methods. They are not relevant to the stack. Into this stack object, you can use it. That's a bad design. The methods you should use allow only the ones that's meaningful to stack, like peek, pop, push, empty, all those things, and not inherit all those things. Not like you could. So what you do is in vector you can insert anywhere in the vector, but in stack it's not allowed. You can only push on the top. So that's a bad design. But we still have it in the Java API. You can never remove it. Once it's there, it's forever. All right, so this is stack, and see how you're going to use it. All right, so we're going to get the next one here. All right, so this is the queues and priority queues. The queues is a data structure. That's the first in, first out. So like if you go to a grocery store and you check out and you are in the queue, so you got a queue, okay? So you follow the order, first in, first out, the queue, the data structure. So how do you store the data in this fashion? So we have a data structure called a queue. In the Java API, we don't have a concrete class for queue. So if you look at the overall diagram, so let me get that picture for the overall diagram. So you're going to see this is the overall picture. So I'm going to go down here. So I'm going to open another tab. I'm going to show you here in this. Right here, this one. So you're going to see this. And here there is no class named queue, but there is an interface for queue. Now, the class we're going to use for queue is this linked list. So linked list, you're going to use the linked list. You don't have to write your own class for queue. Just use linked list. And linked list is efficient for this purpose. First in and first out. So you can always remove from the beginning and add at the end. So this is efficient using linked list. All right, so linked list. And here, look, now it's a priority queue. So priority queue is a subtype of queue. So let's look at the priority queue. And so here is the priority queue. So priority queue now is this. And look at this. It's the this is the interface for the queue. You have a bunch of methods here already defined. So it has this is the offer. So what is the offer? Inserts an element into the queue. So this just note that it returns Boolean. If the insertion is successful, it returns true, otherwise false. So here, another method is a pull. What is a pull? Pull is retrieve and removes the head of this queue, or null if the queue is empty. So if the queue is empty, you don't get anything, but you're going to return a value null. There's no exception. So here's a remove. It retrieves and removes the head of this queue and throws an exception if the queue is empty. So they see the difference between this remove and pull. So there's no exception using pull, but just remove, it may through exception if the queue is empty. So that's the difference. Peek is retrieve, but don't remove it. It doesn't remove it. The head of the queue. So here's peek, return that element in the head of the queue. If the queue is empty, it returns null. That's peek. There's another one, it's element. Element is same as peek, except if the queue is empty through the exception. So look, remove an element with through exception if the queue is empty. So that's the queue interface. And so here, now we're going to see this is the overall design. Here's the linked list. So linked list is right here. It's the subtype of here, the queue and also list. So there's a subtype of the collection. Mm-hmm. And so you're going to write some code to test it out and the queue. So when you use queue in Java, and just use this java.util dot array linked list, not array list, linked list. Okay, using linked list. Okay, so this is you create a linked list for the queue. Next, let's look at the priority queue. Priority queue is like queue, but you remove things with the priority. So the highest priority and gets removed first. So it's like when you go to emergency room, and so the patient with the highest emergency will get served first. So this is the priority queue. You're going to specify the priority. All right, so here are the constructors. So this is no constructor. So this the priority queue. And how do you compare things? You have to compare things to determine the priority. So if you don't specify how you're going to compare it, it's a natural order and using the comparable interface. So here is the one you're going to specify a comparator. So this one here, you can specify a comparator. So how are you going to compare elements? All right, so we're going to write some code here. You're going to see how this works right here. So just remember this. Look at the priority queue. It's a subtype of a queue right here, the queue. So everything, all these methods. So the pull, remove, and peek, and the element. So all these methods we can use. All right, so here I'm going to have this is the priority queue. So we're going to write a test code, and this is the priority queue. So new priority queue. Okay, so look, this is the already here we imported it. So I'm just going to have this new priority queue right here. And this is a string. So you're going to do this offer. Okay. All right. So it is to add things into the queue, string, Oklahoma, Indiana, Georgia, Texas. And now we're going to retrieve it, remove it. So remove everything here in the priority queue and using comparable interface. So if you look at the output here, you're going to see the output is this: Georgia, Indiana, Oklahoma, Texas. So the reason here is the in this priority queue, so the in this alphabetic order, and the smallest the one is considered the priority that has the highest priority. So that's here. That's you're going to see it like this here. All right, I'm going to change it. So if you don't like this order, all right, so you're going to say, hey, I don't like this order. I want a different order. I want just a different order. All right, you can write a comparator here. Put a comparator here. So I'm going to put a comparator here. So this is a comparator here. So I'm going to put the comparator here. I want it ordered by their length. So here, S1. So this is going to be S1, S2. So this is the comparator by their length. S1 dot length minus S2 dot length. All right. So we're going to run the code. Now you're going to see here, it's by this, Texas, Indiana, Georgia, Oklahoma. So you see how easy this is done. You really write minimum code and doing this very neat and actually a very efficient way, and to execute the code as well. So this is, so imagine if you don't have this data structure with this comparator, and you are going to write a lot of code and for just doing this thing. All right, another one here, you can see that we're using, actually, there's another way is, I'm going to have a different order. So reverse order for this, the one we already have, it's alphabetic order. So you have the smaller one and then the large one, okay, and the largest one at the end. So, and I'm gonna swap it and reverse it. So reverse is using, you can use in this collections. There's a method, and this is static method, reverse order to return reversed order. All right. Okay. I'm going to now, I think that's the end almost here. I think there's one thing here we need to do. Okay, at the end is the a case study, evaluating expressions. Evaluating expressions is this. So here, look, you put any expression, and with the operators, addition, subtraction, multiplication, and division. So writing this, all right. So here, like when you do a Google, you put this expression on Google and you get this 9. So this 1 plus 2 is 3 times 4 is 12, and minus 3 is 9. So this is what you get, 9. All right, how do you write a code for this? So writing code for this, it's like this. Here is the code. All right, this is, you have this code. It's called evaluate expression in Java. Evaluate expression, you're going to pass the entire expression as a string, one string here, see quotation marks, and it returns this result, 80. All right, so if you have something run in the expression, so this is the expression, is the incorrect expression, so you get a wrong expression. All right, so this is here in the code, the entire code for this, and you can write it and test it out. So here, so look at this, and if you you're gonna write this 1 plus 2 and times 2, so you can run this code, and you're gonna see that's going to be okay. So here's a 5. So you're getting 5 here. So you're getting 5 here. Okay. All right. All right. This is one you can ignore it. So if you choose a different version, so you're gonna see it's a different version. So this is 5 here. So this is 18, and the JDK 18 is give you some warning. So that's the because of security advantage issue. All right. So this is the code And let's see how this is done. So we're going to need to understand how this works here. This is expression. We need to process it, to scan it. All right, to scan it, here is, we're going to have this program scan the expression from left to right to extract operands and operators, and this parentheses also. So this is the process, the algorithm. So you're going to see this algorithm, and I'm going to let you study this algorithm. You can look at the animation here, how it works. So if you have this, all right, expression. So we're going to look at the animation here. And this, we're going to start this animation here. So scan this parenthesis. We're going to put this parenthesis in this operator stack, this stack here for operators. And now we're going to scan this one. So we can put this number here. This is the operand. We're going to put this operand stack. And now we're going to scan this as one. This is plus. Put this plus right here. And now we scan 2. All right. So now after this, we're going to scan this is a closing parenthesis. So that means everything here we can compute. So now you're going to see here is we're going to compute 1 plus 2. The result is pushed back to the operand stack. And now we're going to get the multiply symbol and in the operator stack and get 4 here. And now you're going to see here next is we have this is the operator minus. It's the lower precedence. So we can now compute multiply. So this is 3 and 4. So multiply and put this 12 back here. And this minus here in the operator stack. And then we can scan this 3 right here. And that's the end. And then we can compute everything and get the result now. All right, so the result is 9. So this is how it works in this animation. So this is all the detailed steps, descriptions right here. What do we do with all these situations? And this is the code to implement the algorithm here. So everything here, the code. All right. We have this programming project. We're going to ask you to modify this code. So we have only the operator, plus, minus, multiply, and divide. So I want you to add the additional operators, add remainder, and add this exponent operator. So we're going to look at this now, and I'm going to go to show you how, give you some hints on this now. All right. So the first, I'm going to get this programming project 2. I'm going to give you the hint for this. Okay. So this is the description. Let's go. The hint is given right here in this, right here, the hint website here. So I'm going to copy and paste here and take you to the website for the hint. All right, so here is the hint. It's this 20. All right, so this is a detailed hint. I want you to read this on your own time and take your time and to analyze it and modify the code and see. It's once you really understand how the code works, it's very easy to modify it. All right, another one I wanted to get is the first here. All right, we're going to write this code for the first one here. So please note that, and here, we're going to perform set operations on priority queues. You're going to use this template to write a program that creates 2 priority queues for integers. Now, please note that you have to use this template. Okay. Use this template. Okay. All right. So I'm going to copy and paste this, and here's the template. All right. So this is the template. You're going to see the template right here. Everything is template. Now you're going to see this is the place you're going to implement your code right here and right here. Okay. So this is the private static, and this is the priority queue. Okay, so it returns this priority queue. Here, the method is store to priority queue. Okay, add integers in line to a priority queue and return the queue. Okay, so you're going to see here is this store to. So you're going to see the code, how you're going to read the code here, store to priority queue, store to priority queue. And here is to increasing order. So here, this is the method here. You can implement this method, increasing order. So get this, return a string that contains the integers in the priority queue in increasing order. All right, so here, read the description. Use this to write a program that creates 2 priority queues for integers. Prompt the user to enter 2 lines of integers. So this is 2 lines. Read each line of integers as a string and extract the integers from the string. So you have to convert the string into integer, use pass int, and add the integer to the 2 queues respectively. Display their union, difference, intersection. Hey, I'm just.
I'm glad. The camera can't work right now.
Okay.
Why are we going to Savannah?
Okay. I just noticed that this code is not right for this program. So here is the I'm going to look at this and make a correction and email you and this. Okay, this.
We can go to a car now.
All right. So I'm glad I checked on this. This one is not the correct one. So this is the different. Okay. Okay. It's interesting where it's different. All right. Okay, I'm going to check on this after the class. Please note that so the due date for the assignment in this chapter is I think it's 8th. So look at this, the due date here. So you can see the due dates. It's so that's the 8th, Friday. All right. Any questions? So I'm going to make a correction on this. The file. It's a posted wrong file on the website, so we need to to find the correct files then. Yeah. All right, any questions?
Nope.
All right, if you have questions, you can stay. So otherwise, feel free to leave. Thank you very much. I'm going to stop share, and also I'm going to pause recording.
Professor?